What up, OMC family? Right at this third take of this video. It's not a battery, it's a storage problem on my phones. Or my dog. Let's try this again. Today, I'm going to show you about a hemocytometer. The blood cell counter. Hemo, or hema meaning blood. Cyto, relating to cells. Meter, measuring. Blood cell measurer. You can use this for spores. And I'm going to show you how to use it to appropriately mix spore solutions for single spore isolation. So this has two sections to it. It has two little grids on the inside of it, kind of like a tic-tac-toe board almost. You can probably see it just a little bit. And I have a camera set up on the microscope, so we'll do some other stuff on there. But just jump right into it. I mean, I have some stuff that I'll show you as we go along, I guess. But if you have your hemocytometer, gotta clean it up a little bit. Let me get some alcohol out of this baby. So I just spray down the hemocytometer with a little bit of alcohol. Dab this baby up. I just used it trying to film this video last time before I was interrupted by more technical difficulties. I'm glad to be able to finally make this video and share it with everybody in the community, which is evolving very fast. Very, very fast. I'm going to throw that in there. And I'm going to see if we can look at this real quick. Hopefully I can do some video editing and jump over here. So we have the center cell right here. That's not going to be used. We're just going to use the 4 corner cells. And remember, there's 2 sections to this. This is the bottom one. 1, 2, 3, 4, 4. Make sure I clean this somewhat well enough. Make sure that's not a spore on there. Okay, yeah, we're good. There might be one on the bottom of the plate, but not on the plane. Is there? No, we're going to go ahead and say no. Okay. So we have our 4 sections. And what we're going to do is add a sample and count up the spores in each one of these 4 sections. So how you prepare one of these is you're just going to leave it right on there. We're going to get a microscope slide. And obviously I'm not doing any of this sterile. I mean, my flow hoods are so loud I can't hear over them myself. I need earmuffs just to work with them. So you would want to do all this in front of your flow hood if you were actually making dilutions for use. I'd usually be wearing gloves, a face mask, a hairnet. ISO'd everything down. And I actually already made a spore solution earlier, so maybe we'll just walk back through and do that. What I did is I got a little bit of water, and if you were really doing this, you would do it sterilely. You can also use some of this polysorbate 20, Tween 20, and what it does, it pretty much keeps the spores from sticking together. It's a detergent. So I do have a sterilized solution of that right here, as well as sterilized water for my regular experiments, as well as sterilized centrifuge tubes. But I also have some that are not sterile at this point that we'll be using. I had a little bit of water right here. I like to use a syringe because they seem to be more accurate drops, and we'll be able to see why that's important here in a little bit. I took a little water, just added into another container, in this case a lid. I took some of the spore sample, which in this case is a Piopini, and I'm pretty much just going to retrace the steps. So we had a bad first take. Kind of see that right there. Just take a little sample off this guy. And you won't be able to see it on the camera, but it almost just looks like I scraped up a little bit of dust on the end of the scalpel. Go ahead and add that to the solution. Get a little mix. And this is just water. If you're making a fresh spore solution, I don't think the spores stick very much. But if you let them sit for a while and then go to use it, they'll probably be pretty stuck together. Go ahead and suck that back up. So now we have a rough spore solution that we can add to hemocytometer. And how you do this is it's through capillary action, so it kind of just feeds under by its own pressure. If you have a drop on the tip of the syringe, watch out not to squirt it. I commonly do that. You can just take it right up to the edge where the cover glass meets the hemocytometer and kind of just guide it up against the edge, and it will feed underneath. Just kind of lightly add it until it's full on each side. And there is better videos on how to use a hemocytometer, but not one for spore isolation. Okay. Have it loaded. Jump back over to the microscope. Here's our center row. Okay, now we can see them. These guys right here. There they are. Go back a little bit. They are easily identifiable on just a second magnification. Less so here. So we'll line up with the top right corner and we'll get a count. Here we're actually going to hop up to the top left. Here you can see about the whole cell that we're going to be counting. look at the first box on the top left, there's nothing. The second box, there's 4. 1 in the third. 1 in the fourth. Going back to the left. Maybe 1. Say that's 1. Another 2. Another 2. 1. Even if it borders it, you count it. So here we're centered in on the hemo, a little bit closer on it. Here you can start to see the spores. Some guys up here, get a closer look at them. There they are. Okay, back out. So where we're going to be measuring is actually these 4 squares right here, these 4 squares right here, these 4 squares right here, these 4 right here, or I guess 16. Those 4 of 16. So if we're looking back up here, get a closer look at it. This would be the first square of the first cell. See 3, 0, 2, 3, 2, 0, 3, 2, 2, 1. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 17. Might write that down. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 seems to be the lucky number on this one. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 2 17s and a 9. One more cell. 1, 2, 3. Four. So we have 2 17s, 9, and 4. Gives us 47. 47 divided by 4, about 12. We'll just say 12. So, if we were going to figure out our solution per milliliter at the standard dilution rate that we're at, or I guess say the initial dilution rate, we would go ahead, we would times 12 by 10 to the power of 4. An easy way to remember that is just 10,000. 10,000 is 10 to the power of 4. And that's going to take your tenth of a milliliter, tenth of a microliter sample that you just measured on average and take it to the milliliter ratio. Each cell is a tenth of a microliter. 1/10,000th of a milliliter. So if we had 12 cells per cell on average times 10,000, that would give us 12,000 spores or cells per milliliter. And that is our current ratio. So you pretty much just get your average spore count per cell, times that by 10,000, and you have your spore solution per milliliter. And a milliliter is equal to a cc. So in 1 cc of the syringe, there is about 12,000 spores, just a little under. So it's going to bring us into these micropipettes. If you have the smallest micropipette you can get, like this one, it goes down to 1/10 of a microliter. So if you're already measuring averages of 1/10 of a microliter, you can pretty much dilute your solution down till it's just on average 1 per cell. So we counted on average 12 per cell. If you had it down to 1 per cell, every drop you get would have 1 spore in it. We were at 12. So I'm going to walk you guys through some averages because I already got them figured out. And you could, pretty much convert your dilutions accordingly to this. So we had 12. Let's say we had 5. Average cell count, about 5 a square. Times that by 10,000, you would have about 50,000 spores per milliliter. We already talked about how every cell is measuring 1/10 of a microliter. So that's where those pipettes really come in handy, because you could just dilute your solution essentially without any math until it was just 1 per square, and you'd be ready to go with those guys. So if you had just an average of 1 per square, times that by 10,000, you're going to have 10,000 per milliliter, or if you divided that by 1/10,000th, you would get 1/10 of a microliter. 1/10,000th of a milliliter. So let's say you're just working with standard drops. say you diluted it down pretty much as far as you can go with a hemocytometer. 1 per 16 squares, so you only have 1 per cell on your hemocytometer in the areas that you're measuring. What you could do is dilute it even further, and you would essentially just take 1 drop of the previously said 1 to 1/10 of a milliliter solution. Take 1 drop of that solution and add it to 499 other drops, or 1 to 499, or a concentration of 0.1%, or 1 drop to 29,450 microliters, or 29.45 milliliters. So hopefully that makes a little bit of sense. And if you were to dilute it down to that rate, what you could have is just a super diluted spore solution where you could just take a standard drop off a syringe, and it gets down to probability at that point. I can link the article that I learned this from, and it should give you a little bit of a better idea, as well as a better idea of how to kind of visualize how the hemo works. But if you follow the dilution ratios that I kind of shared, spore isolation gets really easy from that point on. I'm actually going to do some of those, and I will share the results and kind of guide you along that next process of plating these out and catching them after the fact. This is another thing I got that becomes less useful as you dilute your solutions even further. As you previously mentioned, you would only have 1 cell or 1 spore per cell per 16 squares. And what this gives you is 2 different sections for the top and bottom portions of your hemocytometer. And we know that they have the grid patterns on there. And you can count 5, but most people only count the 1, 2, 3, 4. So that would give you 4 for the top and 4 for the bottom. So as you're going through and you're counting your 16 squares in each cell, you just kind of add them up. And what it's going to do is going to give you a total here on the end, so you don't have to keep track in your head. And then you can figure out your average, and you can repeat as necessary. When you're done with the hemocytometer, just remove the slide, give it a good spray down. Clean it up. Well, I hope somebody enjoyed this video, and hopefully it comes out okay. Till next time. Okay, one thing that I forgot to add. If you're diluting your solutions, an easy way to understand that is, say you had the average 5 per square like we were talking about. What you could do is do a 1 to 4 on that. So you would have 20% essentially. Good way to think of it is if you had 1 drop with 5 spores in it, and then you added 4 drops with no spores in it, you would still only have 5 drops per 4 spores. So it's just a matter of ratios and fractions of figuring out your dilution ratio. So if we go back and we look at our 12 average that we counted up, if I wanted to get that down to 1, we could take it to 10%. 10% of 12 is 1.2, so do 1 drop of that solution to 9 drops of regular water, and that would get us down to a 1.2 on average. So you can kind of just use that to gauge your solutions as well.